सर जी पर क्लासरूम के मुशेर को
क्लासरूम की में शेयर को uh,
जी सर।
let's start today lab. So in the today lab title is the design of an upgrade in on-grid wind power system in Homer Pro. So the title of lab number 3 will be design of an upgrade wind power system in Homer Pro. And the title of lab number 4 will be design of on-grid wind power system in Homer Pro. So what is mean by upgrade and what is mean by on-grid? By upgrade we mean that when we design a system and this system does not feed energy to the national grid or take energy from the national grid, so this is called upgrade. And sometime when we feed our system from grid station, so it is called on-grid. In the case of on-grid, sometime we will give to the grid and sometime grid will give us energy. So in this case, in the end of the month, we will check that how many energy we have given to the grid and how many energy he has the grid has given to our system. So the net when the net energy of the grid station will be greater than our energy delivered to the system, so it means that we will pay some money to the grid, and otherwise the grid station will give us the money. So therefore in the first in the renewable energy we introduce all of the grid station little bit as we were doing labs on these different generation stations. So therefore in first chapter we introduce all of them, that what is hydro, what is wind, what is solar, and now we are studying in detail the solar energy. So when we are doing the labs, so it will be easy for us to understand it, and then we will study in detail in the our theory class. So in this lab, the required component in Homer Pro will be wind turbine. So simple that in previous lab was upgrade lab, as in previous we were not deliver any energy to national grid and neither we will take energy from national grid. So it was upgrade, but the difference was that in previous lab we used the PV cell. In this lab we are using wind turbine. So solar is approximately all over in the country. So we have designed this for the Naushehra, and someone designed for Temargara and Mardan and Peshawar. But here the wind turbine cannot be feasible everywhere. And you know that there are two types of wind, onshore wind and offshore wind. So onshore wind in Pakistan is very good near to the sea area of ocean area of Pakistan, which is Karachi and Hyderabad. So we will design the wind turbine in that area. You are unable to find wind turbine you design for Naushehra and Peshawar, as they are not plain areas like Hyderabad and Karachi, and it is near to the ocean, so the onshore wind are greater in that area. So we will use the wind turbine, and similar to the PV system, we will use the storage batteries that store the system. store the energy uh, for the backup, that when there no wind, if the wind turbine is off, so this storage battery will gives the energy that will be supplied to the load. And as the storage batteries are DC and the wind turbine will be AC, so there will be need of converter which convert AC into DC, and we will apply electrical load, and from the battery it is impossible to continue our load, so we will use the backup generator, diesel generator. In the case of on grade we will apply grade, but in the case of upgrade we will not apply this, so you remove it. The schematic diagram will be look like that. In schematic diagram of upgrade, that there will be AC bus line, and you know that what is mean by AC bus line. The bus line is the line at which the voltage is approximately constant, and this is the DC bus line to which the storage battery are connected. In the AC bus line we have connected the load, and we have connected the generator, and we have connected the our wind turbine. This wind turbine will generate energy, and this voltage will gives to this AC bar, and this load will utilize it. And sometime we will operate the generator, and this generator will give the voltage to the bus bar, and the electrical load will use this energy. And if there is a charge in the storage battery and the wine there is no wine, so they will convert back into AC and give to the load. So this is the on grade upgrade. In the case of on grade, we will remove the storage battery as that the grid station have enough energy that it will be able for, to operate our load. But why we use the wine? So we use the wine to for economical purpose, that our electricity bill is reduced. So no need of cell, no need of converter, and no need of generator. So there will be only uh, wind turbine and grid station and the load. So this is the on-grid system. So what is the procedure? So the procedure you will be easily understand in Homer Pro, but remember that the electric load and select the residential load. So you can do for any commercial and residential and industrial. So in this lab we will do for residential, but the important term is that the peak month will be November, as in November the onshore wind is uh, the onshore wind is maximum. And how we will do this? So let's do in the Homer Pro, then study this, they will and you will be understand. So consider this is our Homer Pro interface. So the first step is that you will search the area. So you can search the area which near to the Karachi. You can design for Karachi and Hyderabad. So let's suppose we are doing for Hyderabad. But remember that there are two Hyderabad, one is in India and one is Pakistan. To write Pakistan with Hyderabad. So the Homer Pro will check that this is the So this is the Hyderabad, and when you zoom it, so this is the near area of the ocean area. So first step is that search the area for which you will use. The second step was that download the resources. So click on resources, and you must be connected to the internet. So no need of solar, as we are design this for only wind turbine. So we will use the temperature and the surface as we are not using solar. So download it. Your resources are successfully downloaded. Then name lab 3, author, write your own name, description, design, and upgrade wind energy system. So write the title of your lab here. Then go to the load and select the load. So as we study that, we will use the peak month November. So there are January and July. So you select the none, and the profile is by default residential. So this is okay, and you can change this from here. By blank you we mean that you can change after that, is this is for industrial, is this is for community. But today lab we want to do our system for residential, and press ok. So as the load has been added, and you know what is mean by this profile, they have already discussed in previous two labs. That what is mean by this, and what is mean by this, what is mean by this, what is mean by this area of the Homer Pro. The second option is that add the power source. So in this case you will go to component and does not use PVCs, and now you will use the wind turbine. So in wind turbine, go to complete catalog and take as per your peak value. So 2.09 mean you can use 2. So this is capacity is 2 kilowatt. So this is approximately okay. And they are temperature sensitive, so we have already downloaded the temperature sources. Some of them does not depend on temperature, and some of them depend on temperature, and some of them are AC and some of them are DC. So we want to design a system that its output is AC, and uh, its capacity is 2 kilowatt. So you can select either this, it depends on you, and do okay. But remember that you must give this value. So let's suppose $5,000 is the, and 5,000 is the replacement, and 20 is that. And Homer Pro optimizer mean that the Homer will do all the process, and they will give us the optimizer results. And previously we have studied that when you click on search page, so the quantity you can change it from to 12 hour or 24 hour, 44 hour, how many hours you want. So but when you click on Homework Pro, so the Homework Pro will do all the required job for you. So now you have added the load. So when you want to store the energy, so you will use the storage system. In storage system, it will be approximately total power. So 11.6. You do complete catalogs and check approximately 10 either some value related to it. Check it. This is approximately equal to 11.25. So this is 10, its capacity is 10. As we will use the generator also, so some of the energy will give by the generator. So it become okay. Now you see that there are two bus bar, one AC and other is DC. To use the converter, but converter will be as per your peak value. So go to complete catalog and take the 2, its capacity is 2. So there are other whose capacity is 2. So you can use anyone. So you can use either this, either above. But you know that its capacity is like peak value. So its capacity is 2 and its peak capacity is 2.09. So this is approximately. You can also use 3, but it will take then some simulation time. Now you have to install the generator. So you can complete catalog, but in this lab I want to inform you about that you can use this generator auto genset. Auto size genset mean that it will automatically update itself as per the system, and you can add it. There are some required changes. So when this area is entirely empty, then you can run it. But and there is some suggestions to do this suggestion. In this suggestion, he says that the storage component optimizer require cost greater than 0. It means that we have not applied the uh, capital cost here. So add the capital cost here. So let's suppose the battery cost is $3,000, either $300. This is simulation based.
Sir,
G.
sir, the capital cost, this is the initial cost, sir.
This is the initial cost. And this is the operational and management cost. So suppose $10 is the 10 either $50 is the operational and management cost. And click on converter and apply here. Converter is approximately $300. So this is $300 and this is $10. But remember that you must apply the controller. But what is mean by controller? That from this system, which type of data you want to control. So click on controller either here, either here. When you click on controller, so there are by default two controller: Homer cycle charge and Homer load following. So what is mean by cycle? So they show that the cycle charging strategy is the display strategy whereby whenever a generator needs to operate to serve the primary load. To serve the primary load. But what is mean by this? The load flow strategy is display strategy whenever the generator operates it produces only enough power to meet primary load. So for example, if this is our load, so it will add some part to it. They cannot control the entire. But in the case of cycle, it will operate. mm, uh, it will the maximum power will be delivered by this. So this will be not optimum. So we suppose you want to just homer flow, so you can remove it. So there is only. You can also add it. Add or remove. You can add here. When you want to add some controller setup, so you can add from here. And when you apply it and you want to remove, so click on it here and remove it. So suppose we want to overload flow. Now you can see that the suggestion place is empty. It means that our system is okay. And now you want to calculate it. When you check two controllers, so there will be two simulation. One will be here and one will be here. When you three, so this portion will be three. One, two, and three. So you can see that the Homer Pro has been give the optimized result to you, and you know that the first will be your optimum value, and you will check that main the first the you if the initial cost or the capital cost is greater but your net present cost is lower, it means that your system is good. Now as we have used one controller, so uh, they write that LF low following, but when you use two controller, so they will give that this is either LC, either is LF. So the optimum result is that in which there are what there are Y generator and converter in storage and converter, and check it. Its present cost is 32, and when you use only generator, so the initial cost will be minimum, but its net present cost will be maximum 46, and its initial cost will be 4310, and its initial cost is greater, but its initial cost is lower. But we will use this as its initial cost is large but its net present cost is smaller. And you can check other graphs as in previous lab, as we have discussed this in previous lab, that click on here. When you click here, it means that what is the maximum cost. So the maximum cost is only due to the this is the due to the wind turbine and auto size jet get set generator. It has approximately second greater capital cost, but This is the battery, and this is the converter, and you can uh, scatter plot as we have discussed, and you can see the table, and you can export here, and you can generate the report and attach to the to this. But suppose you want to design the on grid, so go to design and remove the storage battery. Just click on remove, click on converter and remove it, click on generator and remove it, go to component and connect the grid. So this mean constraints. What is mean by constraint? That this is our load. So how many energy we want to give to this load from grid station, and how we will how many energy we want to apply from the renewable sources. So suppose we want to apply 50% from the renewable sources, but the solar, as we have not used the solar, so write this as 0. It means that we are not use the solar energy here, we only use the renewable energy which is formed from the wind turbine. And you can add the controller here. So let's suppose we want to cycle controller, add it, and let's suppose combine dispatch. What do you mean by combine dispatch? So you can check here. It is every time set that combine the dispatch decide which is the cheapest decision to make load flow or cycle flow. It will provide this information that is the cycle flow is better, either the combine is better. And click here on capital cost, either no need. So you see that there are 3 graphs. One was due to the cycle, other was from this. So it means that, and you should check overall, so there are many, but when you categorize it, give us just one, that it is the best. And this is from the load flow, not from the cycle charge. When you click here, so it means that the maximum energy due to the wind and the minimum due to the grid station. This is the initial cost, and you can annualize it. This is annual cost. This is by cost type. This is by component. Component mean that wind, and this is by cost type mean capital cost, operating cost, replacement cost, and salvage cost. And you can export it in the form of uh, either you can do report and save or open. So when you take the report, so there will be many graphs, and check it that what is mean by these graphs. So hope we have already discussed these graphs in previous 2 labs. So it means that in this lab I want to design the system and then generate the result and check the result, that which result is best and which is worst. So this is all about today labs, but remember that you will be make two labs from here. One will be lab 3. So the title of lab 3 will be to design a to design of an upgrade wind power system in Homer Pro, and the lab number 4, design of an on-grid. So you can do just that, copy this and write this schematic diagram in upgrade. In second lab you use this schematic diagram, and what is the procedure, this procedure for upgrade. So write this in upgrade, and this procedure is for on-grid, to use this for on-grid. And this is your task, that practice the lab with using industrial load profile. In this we have used the what type, we have used the industrial load, residential load, you use the industrial load. And as we have designed the off-grid PV system in previous, so you have to design on-grid PV system for residential. In previous lab, lab number 2, we have designed the PV system for the community. So you have to design this for residential, and it was upgrade. So use design this for on grid. Just follow this procedure. So this is your all about today lab, and I will explain the all graphs, but there is electricity problem, so it means that this is 41%, but it will be reduced to 0 very fastly. So this is all about today lab. You have now you share your screen and do this task, and I will be join you from my mobile phone.